So we have here the introduction to SBAs. It's a very comprehensive document when it comes to SBAs, not just the CSEC, but it applies to KEEP. Now I'm going to be saying this particularly um, due to physics, so applying to physics, but the other science subjects, most of it applies also. There are a couple little differences, but generally it's the same thing. So these are coming from the syllabus. Some of these things are from the syllabus exactly, right? A lot of them are from the syllabus and they come directly from CXC's directives. So please, it will do you well to follow the directives, print this document, make sure and have it with you when you come to labs, all right, and whatnot. So the layout for our class today, right, and this document will be, we have the introduction to SBAs, if you don't know what SBAs are, um, criteria for SBAs, detailed explanation and guide, as in a detailed, and quick graph check, because you get a lot of marks from your graph. So you just want to make sure that you are covered in all your areas and sections. So introduction, what are SBAs? This is an exact excerpt from the syllabus, all right, exact word for word. So school-based assessment, SBA, is an integral part of student assessment in the course covered by the syllabus. It is intended to assist students in acquiring certain knowledge, skills, attitudes that are needed to the subject. The activities for the school-based assessment are linked to suggested practical activities and should form part of the learning activities to enable the student to achieve the objectives of the syllabus. During the course of the study of the subject, students obtain marks for competencies they develop and demonstrate in undertaking their SBA assignments. These marks contribute to final marks and grades that are awarded to the students for their performance in the examinations. The guidelines provided in the syllabus will provide appropriate tasks that are intended to assist teachers and students in selecting assignments that are valid for the purpose of the SBA. These guidelines are intended to assist teachers in awarding marks according to the degree of achievement in the SBA component of the course. All right, so we are here as physics, biology, chemistry are what we call double subjects. They're not double award subjects as agricultural science. Double subject meaning we teach the theory and then you have to earn a practical assessment and practical knowledge on the next hand. I can't just teach you things to look at things alone. We have to be able to work with our hands, physically see how things change and behave in front of us. We have to learn how to troubleshoot and identify problems in front of us. And the only way we do that is with a hands-on experience. Okay, so this is why I am calling you all to school on Tuesday. I know it's the last week of school, all right? But what better way than me still teaching you all in the last week of school? We can sit down, take our time, get our stuff done. So next term, when we start seeing each other a little bit more often, we will be pretty good to go because we still do have SBAs to cover, as I said last day. And let's get them off the ground as fast as possible because the sooner we start, the more work we'll recover and we won't have this big, huge pile up of work in Form 5 to do. All right, so let's start. If we can get about 6 SBAs done by the end of Form 4, we really, really good. All right, that'll be awesome if we can get at least 6 SBAs done by the end of Form 4. All right, so let's continue reading. SBA weighting. Weighting means how much of your final exam it is worth. So SBAs contribute to 20% of your final grade. SBA total is 130 marks. Students who fail their SBA will have great difficulty in passing the subject. Please note, I did not say if you fail your SBA, it's an automatic fail in the exam. No, but usually students who fail the SBA, which are usually labs done over the course of 2 years, if you fail that, you're kind of not doing enough work to pass the exam. All right, students who do not submit an SBA, meaning a student at the end of the 2 years, Form 4 and 5, who do not submit a lab book, who do not submit any labs, all right, would contribute or consist of not submitting an SBA for science subjects being biophysics and chemistry. And so students who do not submit an SBA will receive ungraded and automatically fail the subject. So you could go get total on paper 1, get total on paper 2. And if you did not submit an SBA, you get ungraded and a fail. All right, it's just how the exam works. Once you do not submit a paper, you automatically fail the exam. What the science SBA is composed of? For science subjects, physics, chemistry, and biology, SBAs are in the format of labs and lab reports. With the exception of 3 labs, we will speak about those 3 labs. Your marks will be gained from the written report, meaning you all have to write report. So that is what the lab book is for, to write your lab report. Students are repeatedly encouraged to complete their lab reports in a timely manner, meaning my Form 5s who did their last lab last week are still being asked to finish their labs on time. You all don't need me to tell you all to do something over and over and over. We got a nice complex brain. Let's use our complex brain. For physics, the minimum amount of labs normally done over the course of 4.5 terms. Why do I say 4.5 terms? Because it's 3 terms in Form 4 and 1.5 terms in Form 5. Because usually by second term, the middle of second term in Form 5, SBAs are finished. But that's usually, considering we've lost 2 terms, we can still get a lot of the work done. So if we finish 6 labs, all right, if we finish 6 labs by the end of Form 4, we have 10 labs to do in our 1.5 terms, which is more than enough time to finish. All right, most schools do between 16 and 22 labs. If it was not for COVID restrictions, we would do 21 labs. But we have to look at that. Students must be cognizant of the fact that not all labs contribute to the SBAs and are also part of the delivery of the syllabus. So please note, students, you all, not all of our labs are SBAs. I actually am bound by the syllabus and the rules and requirements to tell you which lab is an SBA lab. All right, I will tell you which lab is a practice lab, which lab is an SBA lab, and which lab is just there to contribute to your knowledge. Again, you all are here to gain knowledge, to learn how things work, both theory and practical wise. We do not take your SBA marks from every single lab. That doesn't mean that you don't do every single lab, because sometimes those things that you learn in a lab comes for exams. And trust me, there's no better way to learn and remember something than to physically do it in class. Students should also be aware that some common labs are used in exam papers, and it's to the student's advantage to have practical knowledge of these topics, as I just said. CXC rules. These are rules set out by the syllabus. This is not me making up things, right, to apply to my lab. All right, I have my own lab rules because my lab is my lab. All right, so CXC rules. Students should write their reports in the prescribed lab book. So this is why you all should have a lab book ready for me by Tuesday. If you didn't get one already, weekend is here, go and get one. All lab books must have a completed index and table of contents. I will go through this with you, what that is on Tuesday. Students are forbidden to remove their books from the lab. They also cannot take their books home. I do not care what other teachers do, what other students say. The syllabus says that you all are not to take those lab books home. They are to remain in school, and I enforce this rule 100%. All right. Some people will say, if you take home the books, you could finish your labs faster. I have proven that wrong every single year, right? Because my students are not allowed to take home their lab books, and usually my marks or my students finish their labs first before the other subjects, because they know to work properly in school, and when you carry it home, things can happen. Do you want something to happen to the book that is carrying 20% of your final grade? Nuh-uh. Do you want to accidentally lose this book? Imagine if you lose your book at the end and in the second term in Form 5. Imagine if you lose the book and now you have to go and write over that 17 labs. You all want to go through that trouble? No, that is a piece of torture. Do not put yourself through torture. Right? I record your marks as you go, and by your books remaining in school, they are safe. For the 16 years I've been teaching at Northeastern College, not a single book, and that will be thousands of lab books, has gone missing under my watch. Not a single one. So your books are safe as they can be in school. So do not think you can carry it home and finish your work faster. It don't happen. Do not think you can carry it home and it's going to be safer. Never. Right? So don't ask. Never ask. I will just tell you no. And last one, the students, you all have to apply. These are rules from CXC. Students should write with standard black or blue pens in their book. Standard blue meaning regular royal blue. Not glitter blue, not light blue, not green blue, some funky colored, some multicolored blue. No, regular standard blue and black ink pens. Yes, it could be gel, it could be carbon, it could be fountain pens. Gel, carbon, fountain pens, yeah. All right. You cannot use any other colors in your book. You're not allowed to use green. Green is actually what moderators use. So when my moderator comes to check out books, they will write in green and black. Red is only for the teacher to mark in. And trust me, I use out 2 to 3 pens, reading pens on all your lab books. Right? We are supposed to write with red in your books. We are supposed to give something called feedback in your books. What is feedback? Feedback is me correcting the work, highlighting where things have gone wrong and what needs to change, including tips and to give back recommendations. Please, you all, the perfect lab book starts off with a whole bunch of writing, meaning the first 2 labs where I write a whole bunch of corrections and notes and scribble things all over. It's meant for you all to read, understand, and apply to the next lab. And the ideal student, they start off with a lot of writing, and as you go through the book, you get less and less writing to the point where I only just put ticks and my signature at the end of your lab. This shows when a student has been properly corrected, when that student is doing what they have to do, and they learn how to write a perfect lab. By the end of Form 4, you all should be writing perfect lab reports where you get all the marks that are supposed to be given to you. So, no questions as yet? You all can raise your hand. I will see when you raise your hand. And stuff when you have a question. I'll take a glance ever so often. And anytime you all see me glance into the next screen, that means I'm looking to see if you're raising your hand. Lab criteria. There are 4 criteria used to assess the types of labs, the types of skills utilized by these students. This applies to both bio and chemistry. How we mark them and what they entail are slightly different because clearly our 3 subjects have different requirements. But same 4 categories. We have AI, which stands for analysis and interpretation. We have ORR, representing observation, recording, and reporting. PD, plan and design. And MM, measurement and manipulation. Each criteria is graded out of 10 and half marks are not permitted. So that means every lab you have will be graded out of 10. On average, please, y'all try to get 9s and 10s now. Right? Because here I am working with you. The first few labs, we will hold our hands together and work together. Right? You can ask questions and I will check and make sure you're going okay. Right? And whatnot. But again, lots of it are repetition. So you learn what to do. Chat, message. I reached there yet, Wade? All right, as I'm speaking right now, what we're doing for people who came in late, I'm speaking about lab criteria. And then at the end of the class, I'm going to discuss what we're doing on Tuesday because not everybody was here early. So continuing. Lab layout. This is the lab layout that you all have to follow for every single lab. Yes, I will put it up on the board every time we all are doing a lab. So it's kind of, you're just playing the fool if you don't follow the proper lab report or layout, consider I even put it on the board for you. So we have aim, apparatus diagram, theory, method, reading results, graph. This is not a heading, but this is always done before your calculations, discussions when necessary, precaution, source error, and conclusion. Your labs must follow this layout exactly every time you all do a lab. And again, I do write it on the board, or I write all the spacings and the headings on the board. So all you have to do is just follow them. Detailed breakdown. All right, so this is a detailed breakdown of what all of these are. We're going to go through that now. Aim. What is your aim? I usually give you the aim. All right, there's only 3 labs that you have to come up with the aim on by your own. All right, so aim is a statement about the objectives of the lab. Usually we seek to show a relationship and or determine the value of a certain quantity. We use topics outlined in our aim to be used in our conclusion. So what is the aim? Just what we're trying to find in the lab. Like if I want to determine what is the resistance of a carbon resistor, I will put to determine the resistance for carbon resistor. Or I can put to determine what a magnetic field looks like. Right? I will usually give that to you. Apparatus, this is a list of the apparatus and materials used in the lab. Again, these are things that I give to you. Diagram. Now, if you look here, I didn't do it for all, but I have written down the expected marks or the general marks for each criteria. So diagram counts for 2 marks in your OR labs, right? 2 marks. And how do you do diagrams? It's a well illustrated diagram of how the apparatus was set up during the lab. There are a few rules that you must adhere to. One, your diagram must be large. How do we know large? At least 1/3 the size of your book. So you all can see what your lab book looks like, and you can estimate about 1/3 of your lab page. Don't worry, you have lots of pages in that book. Your lab book can hold up to 25 to 30. That's a very loud car. All right, your lab book can hold up to 25 to 30 labs at CSEC. At CAPE, it holds 10. That's just to tell you the difference, the sheer amount of writing and work that you expect at CAPE level. But at CSEC level, you all can fit well, probably about 25 labs in that lab book. So you have space. You have lots of space to write and to do your drawings. So one, we want a large diagram. Your diagrams must be drawn with a pencil. Do not use pens or markers, and no shading is allowed. Y'all, I used to get hit by my teacher. Well, not hit her, but it used to always be because I do art, right? So I draw and sketch and do whatnot. So it was really hard for me to not shade. I used to get hit all the time, Miss saying, stop shading, no shading allowed. So I'm telling you all from now, do not shade. I will draw on the board what we can use as shading. So please try to avoid shading. All straight lines must be drawn with a ruler. Please, 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 you all need a long ruler. For every single lab must have a ruler with you all the time. A long, clear ruler. Do not try to freehand any drawing. The only thing you freehand drawing is a curve, right? That is the only thing you all are drawing. Or like for a candle, you can freehand a flame. That's the only thing you're going to freehand draw. Everything else that are straight lines, please use a ruler. And this I will teach you all how to do this. If a distance must be measured or highlighted, it will be noted on the diagram. So I will show you how to do that in the beginning. And then when you have to plan your own labs, you will know how to do it on your own. So diagram, 2 marks. Those 2 marks come from 1, your diagram being a large diagram, and 2, your diagram being properly labeled. If you don't put in any labels, you lose a mark. If you miss half of the labels, you lose that mark. If your diagram is tiny, tiny, little chunky little diagram, you lose that mark. This is not even something to talk about. Get all the 2 marks. Theory. Theory can count for 1 to 2 marks in your AI labs, which is analysis and interpretation labs. This is a brief write-up of the physics behind the topic being investigated. Any equations and derivations necessary for the lab should be stated here. Any theoretical or accepted values should be stated here. The CSEC level, theory is not always needed and rarely exceeds a paragraph. Y'all, I have never seen a theory at CSEC level, meaning just words, writing, more than about 3 lines. At CAPE, it's probably a page to 2 pages, but that's different. But here, it's very, very, very rarely less than a paragraph. There is no limit to a theory, but it must be relevant to the topic at hand. So I don't limit you all. If you all want to write, if you have thoughts to put on page, if you have things you want to tell me, if there are things you had researched and want to relate to me, by all means, go ahead. I don't limit you, right? If you want to write, go ahead and write. But not all labs have theories in them, and those that do have theories, you can get anywhere from 1 to 2 marks for theory. Method. Method can count for 2 marks in your ORR, and for plan and design, up to 4 marks for your plan and design labs. All right, this is a numbered list of steps describing how the lab was executed. Executed is what tense, y'all. This is past tense. So this is telling me, you all have to tell me how you did the lab with a set of numbered steps. So step 1, all right, step 2, step 3, you're numbering your steps, all right, and your method must be in past tense and in third person. Third person meaning you all cannot refer to first and second person pronouns. So no I, me, he, she, we, they, right? Just the or it. All right, because we are referring to how the lab was done. We're not talking about what you did. Speak about how the lab was done and report on how to do the lab. When stating increments to be used, please include the values to be used. I will show you how to do this in the beginning. All right, so anytime we have to take certain measurements, tell the people what measurements to take. Tell the people when you have to take a measurement. So this is the best way to think about a method. A method should be written in such a way that someone can read your method and execute it perfectly without any further instruction. So try to avoid ambiguity such as readings taken, measurements taken. Instead, record something like the time of flight was recorded, the voltage was recorded. You have to be very specific in writing your method. You have to say what you are measuring, what you are taking, what you are doing. So someone, as we said, should read your method and they can perform the lab perfectly without having someone explain it. Right? It's like the same thing, think about a recipe. If you all are making some cake, making a cake, don't come and say, put eggs in batter. How many eggs in the batter do you want? You have to say how many you need, right? Don't say mix butter and sugar. What you're going to do, you're just mixing it twice or you're creaming it till it gets nice and white and fluffy, all right? You have to be really specific in how you're doing your method. Of course, I will help you all out with the method for the first, actually for the whole of Form 4, I help you all out with the method. But you must be able to write in proper sentences and in past tense. So this is where your English, the English you've done for 3.5 years in secondary school, I'm going to see those used now. And my job is not to teach you all English, right? You all are supposed to know how to do that already. Past tense and third person is primary school work. Readings and results. Readings and results can contribute 2 marks to ORR and 2 marks to AI when necessary. Now we have readings. These are without tables. You're going to see what we mean with tables just now. Without tables, you have to follow the instructions given. I will write down the instructions in the method, how to write down your values on the board. I always do that. And state proper units when necessary. What are units? Units are the quantities we use to measure our things with. So if I'm measuring distance, I measure in meters. If I'm measuring time, I measure in seconds. If I'm measuring current, I measure in amps, and so forth. But again, I will help you all out in the first set of labs, and then after that, you're supposed to remember. Tables. Sometimes we have to take multiple readings of certain quantities, and it's best to put it in a table. So students must use proper headings and formats. So the best way here, so I have an example. I have mass, time, and time squared. Now, if you look here, you're going to see that we have mass slash kilogram, time slash seconds, time squared slash second squared. You are to record the unit in the top table or the top column, top row, sorry, the top row of your table. And when you record your unit at the top row, you do not need to come and write kilogram throughout. You don't need to do that again because it's recorded at the top. So don't come and say, well, okay, well, mass was in kilograms, right? And you're going to write 100 kilograms, 200 kilograms. You don't need to do this. It's unnecessary because we already have the unit written at the top. Once we have the unit written at the top, you don't need to write it again in the table. Because look how nice and neat the table looks with just having numbers in it. It's a nice, easy table, nice, neat table, and whatnot. So I always will give you the proper headings at CSEC level. I will give you all the headings needed at the CSEC level for your table. At CAPE, you kind of had to figure out some on your own. Right. If a calculated value, if calculated values are to be recorded in a table, an appropriate heading and unit must be recorded. So an example of calculated readings will be here. Here it will be time squared because I had asked you all to calculate, or I'll ask the students to calculate the square of time. So what you did here, 5.6 squared, and you write in the answers to 2 decimal places, always to 2 decimal places, 31.36. So that's what you do. All right, anytime you have to put calculated values in your tables, make sure and put the right headings. But I usually give you the right headings anyway. So let's go through that. Tables and readings. Readings usually account for 2 marks OR, 2 marks AI. Graphs. Graphs are, let's look at this, where the bulk of our marks lie. Not all labs, we check for everything. Darian answering why do we need time squared? That was needed in that specific lab. You will see why we have to do things in specific labs, right? Because sometimes when we get tables, we have to go and calculate things in other columns. All right, so you will see when we do in the lab, when we have to do calculations that apply to the lab. This was just an example. Right, exact graphs. As we did last time, there are many details that must be recorded in your graph. All right, so we are going to look at ORR right now. ORR marks come from labeling your graphs properly. All right, 10 up to 10 marks can be gotten from your graph, just your graph, by labeling properly. So 1, we must label or put a title at the top of our graph page, and it must be a proper title. You cannot come and say mass versus time. No. Right? You will think about what you're writing. You will look and see what we are plotting. Remember, your graphs are always stated of as the Y quantity versus the X quantity. Right? It's always Y versus X. So if I give you a graph where we are looking at how mass and oscillation time change, don't come and tell me that's mass versus time. No. That's just not a proper title. You have to label your things properly. So a proper title will be graph showing mass of pendulum versus time of oscillation. When you all are doing your labs, you will figure out your proper title. It's not hard. Proper scales and recording of the scale used. So if you all use a proper scale, you get a mark. If you record your scale, as in write it down on the page, you get a mark. We went through the rules of use of scales in the graph. Mark, your mic is on. Question? No question? All right. You are not allowed to use increments or values for increments that cannot be easily broken up into fives or tens. What are increments? If you all remember, remember when we did graphs, we took double lines. Remember that? And those double lines had 10 little small lines in it. Right? An increment is the distance, the values that we are using on the graph. So you cannot use values like 3, right? You can't go and use values like 6s, 12, and whatnot. Not allowed to do that. Or weird numbers like 4.575. I can read any graph possible, but this just, oh gosh, use a nice sweet number, 5. When you have to come up with your scales, use a really nice, easy number that's quick to work with. Don't take complicated numbers. All right, so we can always use numbers like 1s, 2s, 5s, 4, 10, 8.1, and so forth. Numbers that are easy to break up and to count into tens, please use that. The suggested way to record your scale, we will go through this on the board in school for our second lab. I'm not going to go through this now because it will make no sense to you, right, when we go in the lab. Axes, label your axes. This is 2 marks for your lab. 2 whole marks to label your axes properly. So you must state what quantity and unit are to be used on each axis. So when you have to draw a graph, you have to write down what goes on the X and what goes on the Y. Students regularly have issues doing this. And I tell you all, this every year, students don't know how to label their graphs properly. When I tell them to label their graph, some smart man will come and write Y and X. That is not labeling your graph. Labeling your graph is telling me what is going on your x-axis and what is going on your y-axis. Right? The best tip, I actually give you the labels, but you just have to know how to find it and how to use it. Best. Y'all, this is a perfect way to get that mark perfect all the time. Let me get that 2 marks easy now. Right? The best, use the entire label used from the table. So example, if I ask you to plot a graph of time squared versus mass, time squared will mean that time squared goes on your y and mass goes on your x. So what you're going to do, you're going to take the exact label. You'll see this exact label I have on from the table here. Mass is mass kilograms, and that goes on the x-axis. You write that exact thing on your graph, and this will tell you the quantity that is being measured and the unit that is being measured. You get marks for stating both. If you don't state one, you don't get the mark at all. All right, so here if I say time squared goes on the x-axis, just take what you have written in the table exactly and write it on the graph, and you get your mark. All right, so it's a little tip to remember from now on when you're doing your graphs. What else? Plots must be a small x or circle with a dot. If you put just a dot, if you just put a dot in your graph, you get no mark for plotting your points with an x or a dot. Y'all, this is the stupidest mark to lose. If I'm telling you to plot a graph using a small x or a dot with circle, and you're going to come with your stubborn self and write dots across the page, you're not asking for me to clout you. Why is it a mark you want to give away? Honestly, you get to the mark, you're just writing an X in your lab book. All right, so please, this is CXC rules, an X or a circle with a dot. You must draw your best width line or curve across the page, not within the confines of the plot. We'll go through this in school. Accurate plotting with no excessive rounding off. So we'll do that. Calculations, I'll just go through the calculations part quickly, and then we'll wrap up this part. The rest you can read on your own, and we will discuss it in class. Calculations can take up to 6 to 10 marks for your AI lab. You want to give away those 6 to 10 marks, considering you're basically allowed to have calculators, notes, and you can help each other in the lab. It's not an exam where you have to run strictly on mental and memory. You're allowed to bring your lab books, your graph books. your notebooks, textbooks, anything you want to your lab to help you out with that lab. So for gradient calculations, you have to choose two non-plotted points. We did go through this, but we'll go through it again in, why didn't the blue come up? Okay, all right. So we'll go through this. You have to choose two non-plotted points from your straight line. These 2 points must be far away from each other. We have an example below. You must state your gradient formula accurately. Remember, we went through this. You have to write this down properly, right? Y2 with a subscript 2 indicates this is Y and this is the second value. This is what we call labeling. Y squared means Y by Y. We're not doing Y by Y. We're taking Y1 and Y2. So if you all come and write down the formula, meaning if you write down just the formula for your gradient, you get a mark for that. All right. Do you want to give away the mark? Because if you end up stating this, you get it wrong. One time, you get it wrong. State your gradient formula properly, please. All right, then we have to accurately read off the points in the gradient, accurately calculate your gradient, and state your gradient unit if possible. We will go through this in school. How do you calculate gradient unit? It's just the y-axis unit divided by your x-axis unit. You get marks for all of these. So let's see here. You get 1 mark for non-plotted points, 1 mark for far away, 1 mark for formula. You get up to 2 to 3 marks for your grade for these 2 points. You get 1 mark for stating your gradient units. Simple things. Some of them you don't even have to calculate. You just have to choose your points. You just have to write down a formula that you will use dozens of times in your physics life. Dozens. Right? So again, if you keep this, you print this, and you refer to it every time, you're going to have perfect labs. Alex is coming back in. An example on how to do this. Now, we will go through this example the next day because time is running. All right, so I will go through this properly with you all in the class. No, actually, no, we have time to do it. Let's go through it quick. All right, how to do gradient. So I have a graph here of gradient showing lab with a graph showing gradient, graph showing current versus voltage for filament bulb. So I have current with amps on the y-axis and voltage V on the y. Now, when you're all plotting your graph, say you've gotten these readings, you draw your best fit line, your line goes straight across the page. See how the line here goes straight across the page and not just here with the points. You have to draw that line straight across. So that's why you all need a long, clear ruler to draw your graphs. Get a long, clear ruler, please. All right, you need this long, clear ruler, a pencil, pen, calculator, and a good eraser for every single lab. So make sure to have those: pen, pencil, good eraser, calculator, and a long, clear ruler. Long, clear ruler being a 30-centimeter clear ruler. So if I want to choose points for gradient, I usually tell them, this will sound familiar to you all. Take a point somewhere at the top of your graph and take a point somewhere at the bottom of your graph to find your gradient. Don't come and choose a point somewhere here and here. Don't come and choose 2 little points to give you what we call a small triangle. This is how we know when we students have taken proper points. We call it small and large triangles. So take a point somewhere at the very bottom, take a point somewhere close to the top. Take a nice comfortable point that's easy to read. Then you are going to write out your formula. You have to read your points accurately. So if you see here, my x1, y1 is x1. You read down to find x is 2. You read across to find y is 0.3. And my x2, y2, write it down. Don't just think about it in your head. If you scroll up, you're going to see it's coming down, it's 41, and going across 2.75. So you're going to get 41 and 2.75. Plug it into your formula. So it's going to be 2.75 over minus 0.3 over 41 minus 2. Please work out your denominator and numerator first, and then hit your calculate, your equal sign. We have our answer, and then we have our units. So we will do this again. This is for you all to use. I will post this up in the classroom right afterwards. So use it, print it, apply it. Calculations. Final calculations are usually 2 to 5 marks in your for AI. Discussion. Here, remember for calculation, you have to show all your working. Don't just write down answers. If you just give me an answer, you get 1 mark. If you show me all your marking and working, you can get anywhere up to 2 to 5 marks, depending on the lab. Discussion.